Hello everyone. In this video, I would like to compare the groupby function in Pandas with SQL. Now, if you are from an SQL background, you already know the concepts of aggregation and groupby. While the concepts remain the same, the way it is implemented in Pandas is slightly different. We will go through a few examples here to understand how the groupby functions in Pandas. So to start with, let me load a small data set. So I have a data set prepared from a dictionary over here. So I'll just put it into a notebook. Let me load the libraries first. Okay. And then I print out the data frame. So here we have it. So we have city, country, and then humidity and temperature values for around 13 cities over here. Now, to compare it with the SQL groupby, I have loaded the same data set to a MySQL table. So this is my MySQL command line. Let me query the table. Select star from city weather. So this is my data set over here. So this is the same data that we have in a Pandas data frame. All right. So let's see. First of all, let's see how a simple groupby works. So in SQL world, so suppose say I want to find the minimum city temperatures for each country. Now to do that, in SQL, it's a simple query. Select country, min of temperature from city weather, and then group by country. So this is going to give me the minimum city temperatures for each country. So there you go. So this is the result. Now let's see how we do it in Pandas. So before I go ahead and run the Pandas statement to do a groupby, let me just explain the process that goes behind when we issue a groupby command. So this is a small illustration over here. So this is the data set that we just saw, the country, city, humidity and temperature data. Now a groupby normally goes with an aggregate function. So basically in Pandas, this is split into three steps. So first is the split, then an apply, and then a combine. So basically it splits based on the column that we specify for grouping. It splits or creates a logical split of records, and then it applies the aggregation on each group, and then it combines the result to give us the final result to us. So here in this illustration, the split is first step. This is when we call the groupby function. Then it applies the aggregation function. We have a set of aggregation functions that we can use on a Pandas data frame. So I have listed only a few of them here: min, max, mean, standard deviation, variance. All these are aggregation functions. And then finally it combines all of them together to give us the result. So this is the final result if you are taking a min of temperatures. So now if you go back to our notebook, let's see how we do a groupby in Pandas. df.groupby by equals the column name based on which we want the grouping, and then we select the column on which we want to do the aggregation, and then the aggregate function. So if I run this, I'm going to get the same result as we saw from the SQL output. So I think we need to understand this step a bit more closely, because there are a lot of things that we do here in this single statement. So let's break it up. So I'm going to take this first part and then run it. So if I run this alone, it says it has returned an object of type data frame group by. Now data frame group by is the resultant object of group by function, and we'll have to see what goes inside this object. So to do that, let me assign this to a variable, and then I run it here. And now, as we saw in the illustration, we have seen that it creates logical split. So each split is a group. Now we can see the groups inside this object. If you just print grp dot groups, it's going to give a list of groups inside. So the grouping column is the country. So for each country name, it's going to create a group. And this is the dictionary basically. So the key value is the country column, and the value is a list of row indices. Now these row indices are the indices of the actual record that belongs to that country. So if you look at Brazil, we have got index 8 and 9. So these two records. So similarly for other countries, they keep a list of the row indices that belong to that group. Now, if you want to see the full record, so basically the group grp object over here, it has got the full record in it. Now, if you want to see what are the groups and what are the records under each group, let's try this. I'm going to iterate over the grp object. Group name, print, so if I run this, you can see the group name over here and then the full set of records that goes under this group. Similarly for all the groups in it. Now it's up to us to decide what aggregation we want to run on these groups. So if you do a describe of the grp object, it's going to give you the description or the statistics for all the groups inside. It's not just for the entire data frame. It's going to give the statistics for each group or logical group in it. Now, if you pay attention, you can see that the country column has become the index. Now, if you look at the earlier output, you can see this country column has become the index of the resultant data frame. Now, if you don't want the country column or the group column to become the index, what you can do is df dot group by equals country, and then another parameter as index equal to false. So this will make sure that our grouped column does not become the index of the result. Now we select the column we want to be aggregated upon, and then we apply the aggregate function. Everything else remains the same. We just added this particular parameter to the group by function. So if I run this, there's an extra O here. Right. So you can see that the indices have got defaulted to the regular integer values, and then you have the country column as a regular column over here. It's no longer part of the index. So that's how the simple group by functions. Now let's say I want to include, so let's go back to our SQL query. Now I want to include the city column over here. Now we have got only the minimum temperatures for each country. Now I want to include the city column also into this select query. Now by the rules of SQL, if you want to include a column here, that column has to be part of the group by itself. or otherwise you have to wrap it up in a aggregate function. So that's not going to work for us. So if you want to add a city column over here, we cannot run a straightforward query. So what we do here is we will have to create two subqueries, and then join them together. So let me try this. So I'll create two subqueries with aliases A and B. So I'm writing the first one, A dot country, A dot city, A dot temperature from city weather, and I give it an alias A. Now my second query, select country, min of temperature as min temp from city weather group by country, and I give the alias name B. So we have two queries. First one, it just selects everything from city weather table. Second one, it's the same group by query that we wrote earlier. So this selects all the grouped values or the aggregated values, basically all the minimum temperatures and the countries. And then I join the country and the minimum temperature to my complete data set to get the actual record. So I apply a where clause to join that. It's an inner join. A dot country equal to B dot country and A dot temperature equals B dot min temp. Okay, so now we have got the country, the city and the temperature. So basically the city where the temperature is the lowest within a country. Now this query will seem a bit complicated for those who are not familiar with the SQL style of coding, but when it comes to Pandas, it's not that complicated. So let's see how we can write the same thing in Pandas. So here in this query we got the country and the minimum temperatures. Now I'll just copy this, and instead of the min function, we don't want the temperatures here. So instead what we will do is we'll pick up the indices, or the raw indices of these records, the respective records which has got the minimum temperatures. So in order to get that, I'll use the function called idxmin. So it gives me the indices of the minimum temperature value records. So if I run this, I'll get the raw indices, and these records have the minimum temperatures within a country. Now I use these raw indices to fetch the complete record. So I use the data frame dot log function. So this will give me the entire record that has got the lowest temperature in each country. So now if you want, you can apply any kind of filtration on this, because you have got the entire record over here, and the raw indices actually correspond to what we got here. So this is how you select a non-group by column in a group by query. So say we want to count the number of records within each group, and how do we do it? In SQL, we have this count function that we can use along with the group by. So let's see, suppose say I want to count the number of cities, or in fact it's the number of records within each country, or for each country. So in SQL I can write country count star from city weather group by country. So this will give me the number of records within each country. So basically this count star, the star inside the count doesn't have much of a meaning. You can pass in count of 1, count of 2, it doesn't make any difference at all. Basically this count and the value that goes inside the count is basically just a placeholder. You can even place the column name like city or anything here. It just counts the number of records within each group. So that's what it does. Now the same thing, if you want to do it in Pandas, this is how we do it. df dot group by equals country, let's say as index equals false, and then you select the column name city dot count, the aggregation function. So this gives me the count of cities within each country. Now, so the basic premise is that for Pandas to do the counting, it needs at least one column to count. Suppose say if you have used all the columns in the group by clause, then the count doesn't function much like this. So I have another data set. Let me load that as well. So I'm loading another data set, a smaller one. In this case, it has got a make and body style. These are data about vehicles, cars. So let me just print it out. Okay, so it just says Alfa Romeo has got 2 convertible models and 1 hatchback, and Audi has got 2 sedans. So if I want to do the same count here, so here I want to pass in a list of columns. By make and body style. So I want to group by both the columns, and I want to count body style. So if I run this, for some reason Pandas has got some problem with a syntax like this. Basically the reason is body style is already part of the group by clause, and it becomes the index part. So even if we specify as index equal to, so now let's remove this as index equal to false and see what happens. So now it gives us the count, but your make and body style, both the columns that we use for group by has become part of your index, and we only have the counts over here. So let's store it into a variable x, and let's take the type of x. So if I run this, what we are seeing is the x has become an object of Pandas series. Basically, a series is basically a single column data structure. So it doesn't have anything else. Both columns have become the index of the series object. So now even if you try to reset this index, if you reset this index, Pandas has got a problem with that too. It says body style already exists. So basically you can get the counts, but you won't be able to get these columns as part of your resultant data frame. So how do we resolve this? Now there is another function called size. So count is an aggregation function, whereas the size is not an aggregation function. It just gives the size of the group. Now I'm just replacing count with size, and then I'm going to run it. So now it is giving me the counts over here. So let me reset the index, or better I say as index equals false. So now it gives me the count as well as the column names. Now if you want, let's try resetting the index. Okay, so now it allows us to reset the index, and make and body style have become columns, separate columns in itself, or regular columns, and the index has been reset to regular integer values, and we also have the count values. Now if you want to assign a name for the column here, the count column, we have to do it here. So we have got the count column with city count. So this is one special case which even I encountered and couldn't figure out for a long time how this works. So I thought it may help you in if you encounter this somewhere. Next thing that we normally do along with a group by clause is using the having clause. So having is used in SQL when we have a requirement to filter out some of the grouped records. So it always operates on a grouped set of rows. So let's see an example. So for example, if you want to find out countries where the minimum city temperature is above 15 degrees Celsius. So in such a scenario, we already have the grouped records with the minimum temperatures, and then we do a filter on top of it. So there, it's not the where clause that we apply, but we apply the having clause. So let's see a simple example. Select country, min of temperature as min temp from city weather, and we do a group by on country. And then, so if you do this is the same query that we did some time back. So this gives the minimum temperatures from each group. Now on top of this, we want to apply the having clause, so that we filter out records having minimum temperature less than 15. So after the group by, we specify having min temp. This is the column name that we created here as the minimum of temperature. Min temp greater than 15. So there we have got all the countries with minimum temperature values above 15 degrees Celsius. Now to do this in Pandas, it's a trivial statement because the Pandas gives us a data frame having the minimum temperatures, and we can filter that out as usual. So it doesn't require any special syntax or anything. It's the normal slicing operation that we do. So df dot group by equals country, let's say as index equals false, so that we don't want to make the country as the index column, and then we select temperature and then the min. So as usual, this is going to give us all the minimum temperatures. Now let's assign this to a variable, say x. So x has got all this complete data frame there. Now we filter out records from here. So to do that, x of temperature greater than 15. Now what will we get if you run this? We are going to get a set of Boolean values. So basically a true wherever the temperature value is above 15, and for the remaining records we will get a false. Now we use this true false list to filter out the original data frame. So it's X of this. So this is going to give us the countries with the minimum temperature greater than 15. So that's it. So we have covered almost all the basic simple usage of group by in SQL, and we have seen how we use the same thing in Pandas. So if you have any comments or doubts, you can put them right below this video, and all the code that we saw in this video, you can download them as IPython notebook or basically JupyTer notebook, or you can see the textual representation of all these in the link given below. Thanks for watching.